Welcome to our full Year 10 probability video. In this video we are looking at the addition rule. So our learning intentions for this topic are that you'll understand and know the addition rule for finding the probability of the union of two events. So we're getting that terminology now, that union, okay? To be able to apply the addition rule to unknown probabilities, to find unknown probabilities, and to know the meaning of the term mutually exclusive. So in terms of union and mutually exclusive, we've already dropped that into our videos already. So we're kind of just embedding what we've already heard about. So let's have a think about this term, okay, the union of events. So we knew we could have in our universal set, we might have subsets. And we said our subsets could be, for example, we could call them subset A, subset B. So if we was looking at rolling a dice, subset A would be a group of events that we've decided. So we might say, if we're doing a 10-sided dice, we might say all the even numbers or all the odd numbers. And then B would be another subset. Then in the middle there, that's that intersection. So the intersection of A and B, the sets that they share. And then the union is that whole area, so A, B, and the intersection. Okay, so then we talked about mutually exclusive. And these are events that have no intersection. So they're clear, defined events that do not interact at all. So you can see that example there. We've got three different events, A, B, and C, or three different subsets, A, B, and C, and no interaction. Whereas underneath, the example is not mutually exclusive because we've got the intersections between each subset. Okay, so still doing a bit of revision here. Remembering that S, and there are other symbols, okay, but I'm using S here, is that universal set. So in this example, we're doing all the numbers, that should say all numbers between 1 and 10, but including 1 and 10 as well. Our subsets are going to be A for prime numbers, so subset A is prime numbers, and subset B is going to be our even numbers. Okay, our diagram should appear in a moment. Okay, so we've got prime and even. And here we have a look, in our even numbers, we've got 1, 2, 3, 4, 5 even numbers. So in subset B, we've got 5 even numbers. And in subset A, which is our prime numbers, we've got 1, 2, 3, 4. In our intersect, we've got 1. Okay, and in our union of A, so the complements, the opposites, we've got 2 values. And you think our total universal set, there were 10 values, yeah, because we was going from 1 to 10. Okay, so the probability of being a prime number. So that's going to be 4 out of 10 because we had 10 values, okay, and there's 4 primes there. Probability of being an even number, what do you think? 5 out of 10, okay, so we've got 5 even numbers and our universal set, there was 10 values. Okay, P, neither prime or even, so I should have put there the union of A and B, shouldn't I? Okay, so neither prime or even. It's 2 values out of the union. 2 out of 10. Alrighty, so the probability of being prime and even. Well, if we had prime that was 4 out of 10, 1, 2, 3, 4. We had even that was 5 out of 10, 1, 2, 3, 4, 5. So you would imagine that prime out of even prime and even would be 9 out of 10. You'd think you'd just add them together, hey? Then, if we think back, those that were outside the union, those complements, okay, we had 2 of them. So the 1 and the 9. So that would give us a total of 11 subsets, 11 sets. We've only got 10. So there's something wrong here, isn't there, when you think about how we added these together? Because we need this to be 10 out of 10 to be our full set, not 11 out of 10. All right, there must be a rule that we need to learn. And it is the addition rule. Okay, so if you have a look here at these 2 infographics, these summarise everything so well. If we're looking at mutually exclusive on the left side, where they have no intersection, that's okay, because you can add all of the subset values to each subset value, add them together, cool, you get your entire set, okay? However, if we've got the overlap, we need to do something a bit different. So we add A and B, so everything that's in all of A, everything that's in all of B, and then we're going to take away whatever's in the intersect there. That will then give us the total of our union of A and B. Okay, so we've got another diagram here. So let's think about it. This diagram really breaks it down. So we add everything that's in A to everything that's in B, and then we subtract what's in the intersect. That will give us the entire union of A and B. Don't look too deeply into this one, guys. Alrighty, so let's go back to our example and see if we can figure this out. So in A we had 4. In B we had 5. In our intersect we had 1. So we're going 4, everything that's in A, plus 5, everything that's in B, minus our 1. Okay, now remember that's 1 because there's only one value. Don't worry because the value says 2. There's only one value in there. Number 2 is our value. All right, so 4 plus 5 is 9, minus 1 gives us 8. And then, did I do it? Oh, hang on. Okay, yep, so our prime plus, yes, I see what I'm doing. So we've got our prime value, we've got our even value, and then what we're saying is our prime and even is 8 because we only count that value once. So we've done what we did on the slide before. Now we look at those 2 that are outside the union. If we add them together, we get our 10 out of 10. So we got that 8 that's in yellow. Let me just go back that one slide here by doing our addition rule, where we go all of subset A plus all of subset B minus the values that are in the intersect. And that, team, is our our addition rule. I'll see you in our next video.